Imagine the absolute unbroken silence of deep space. For billions upon billions of years, the soundtrack of our cosmos has been a faint ambient hiss, the cosmic microwave background radiation, the whisper of the Big Bang itself. It is a silence of unimaginable scale and duration. Then, one day this year, something broke that silence. Our planet's most advanced listening devices, sophisticated radio telescopes scattered across continents and separated by thousands of miles, all pointed toward the heavens, constantly monitoring the electromagnetic spectrum for anything unusual. And they found it. It wasn't the random burst of a dying star or the steady pulse of a distant quasar. What came through was a focused, deliberate transmission, a single, clear pulse that registered on multiple observatories simultaneously. Let that sink in for a moment. This wasn't a single telescope picking up a glitch or experiencing a malfunction. Multiple, independent facilities using different equipment all detected the exact same signal at the exact same time. It pierced through the darkness with unmistakable clarity, was recorded, and then there was only silence once more. No repetition, no follow-up, no discernible pattern we could analyze for deeper meaning. Just a single, solitary announcement, an announcement of a presence we were not prepared to encounter. This signal came from a guest, a traveller that had journeyed from the interstellar void, from the absolute darkness between the stars, for potentially tens of thousands of years before quietly entering our cosmic neighbourhood. Its official designation is 3I Atlas, and it is behaving in ways that defy everything we think we know about the universe. Let's rewind to July of this year, when the story truly began. Astronomers using the Atlas Survey System, that's the Asteroid Terrestrial Impact Last Alert System, a network of robotic telescopes designed to be our planet's early warning system against incoming asteroids, detected a faint point of light moving against the backdrop of distant stars. This is routine work for Atlas. They find new objects all the time, but within days, as orbital data was refined, a startling truth became apparent. This object wasn't one of ours. It didn't belong. Its trajectory was all wrong. Think of our solar system as a set of nested rings on a cosmic pond. Objects born here follow predictable elliptical paths, captured by the sun's gravity like a tetherball spinning around a pole. But 3I Atlas wasn't circling. Its path was a hyperbola, a sharp, open-ended curve. It was a bullet fired from an unknown region of the galaxy, passing through our system, destined never to return. The calculations were undeniable. It didn't originate from our asteroid belt. It didn't come from the Kuiper belt, that distant icy realm beyond Neptune. It didn't even emerge from the Oort cloud, the vast theoretical sphere of comets thought to surround our solar system at its outermost edge. No, this visitor came from the interstellar medium itself. But what truly left scientists breathless was its velocity. 3I Atlas is moving at approximately 152,000 miles per hour. That's over 245,000 kilometers per hour, or about 68 kilometers every single second. To give you some context, a typical asteroid in our solar system cruises along at maybe 20,000 to 30,000 miles per hour. A comet, when it gets a powerful gravitational kick from swinging close to the sun, might briefly reach a peak speed of 40,000 or 50,000 miles per hour. Our fastest spacecraft, the Parker Solar Probe, only reaches its record-breaking speeds by falling deep into the sun's gravity well. This object, 3I Atlas, is travelling through the outer solar system at a speed 3 to 5 times faster than anything we would consider natural. There is no gravitational slingshot that can account for this. It arrived with this incredible velocity already baked in. At first, the scientific establishment watched with cautious curiosity. We had, after all, seen interstellar visitors before. In 2017, the very first one was detected, the infamous Oumuamua, a bizarre, cigar-shaped object that tumbled erratically and accelerated in a way that defied a simple explanation. Then, 2 years later, in 2019, 2I Borisov passed by. Borisov looked and acted more like a conventional comet with a visible tail, but it still travelled with that characteristically high interstellar speed. These events were profound, opening a new window into the galaxy, but they were seen as rare, random fragments cast off from distant star systems. 3IA Atlas, however, has presented a list of anomalies so long and so fundamentally strange that it shatters any notion of being just another piece of cosmic debris. Let's go through the evidence, piece by perplexing piece. We can start with its very surface, its luminosity. When the James Webb Space Telescope turned its incredibly sensitive instruments toward this visitor, the data it sent back was remarkable. Natural objects like asteroids and comets are essentially primordial rubble, their surfaces pockmarked, irregular, and rough from billions of years of formation and collisions. They are dull, scattering sunlight in chaotic ways, causing their brightness to fluctuate wildly as they tumble. But 3I Atlas reflects sunlight with a uniformity and brightness that astronomers have described with language that is rarely, if ever, used for natural objects. The phrases being used in private reports speak of a surface that mimics polished metal with a reflectivity suggesting an engineered smoothness. The way photons bounce off its surface is not random. It's coherent, as if hitting a smooth, crafted facade rather than a chaotic, rocky landscape. Then there is its rotation. Natural objects, being the products of countless collisions, do not spin with grace. They tumble end over end, they wobble, their rotation rates change, and their orientation shifts randomly. But 3I Atlas rotates with mathematical precision. Its period of rotation is stable to an incredible degree. More telling, the brightness we observe remains remarkably stable, which tells us that the same surfaces are consistently facing our direction. There is no wobble, no tumble, no irregular spin. What we're witnessing looks less like a natural object tumbling through the void and more like something that has been deliberately stabilized, something that knows exactly which surfaces should face which direction. It spins like a perfectly balanced gyroscope, not a randomly shaped rock. The weirdness deepens when you look at its heat footprint. When Webb's infrared instruments observed 3I Atlas, the expectation was to see a typical thermal map, a warm side facing the sun, a cold side facing deep space, with these temperatures shifting as it rotates. But the data told a different story. One part of the object remained consistently warmer than the other, and it stayed that way over time, independent of its rotation relative to the sun. How is this possible? There are only two radical explanations. One, 3I Atlas is generating energy from within, a process unknown to any natural rock or comet we have ever studied. Or two, it contains an active system for thermal control. Picture a modern spacecraft with heat pipes and radiators, complex technology designed specifically to gather heat from one area and spread or reject it from another to maintain operational temperatures. The data from 3I Atlas is eerily consistent with such a system. Let's examine what this object is actually made of, because the spectroscopic analysis has left researchers genuinely baffled. Spectroscopy allows us to know an object's composition by breaking down the light it reflects or emits into a rainbow of frequencies. Comets are dirty snowballs composed primarily of water ice mixed with dust and rock. As they approach the sun, that ice sublimates, turns directly from solid to gas, creating the characteristic tail. Water vapor should be the dominant emission by a huge margin, but in the cloud of gas surrounding 3I Atlas, the level of carbon dioxide is 10 times higher than the water vapor. This ratio is completely backward. It's the chemical opposite of every single comet we've ever studied. But the metallic signatures are where things become truly bizarre. The data shows nickel pouring from this object in extraordinary quantities, massive amounts of vaporized nickel in the surrounding cloud. Meanwhile, iron, an element that should be abundant, that should dominate the metallic content of any natural space rock formed in a supernova-seeded galaxy like ours, is virtually absent. This is like analyzing a mountain and finding it's made of pure gold, but contains no silicon or oxygen. it violates the fundamental rules of cosmic chemistry as we know them. And to top it off, the analysis detected complex organic compounds, long carbon chains, and intricate structures that display a level of organization we don't typically associate with the random chemistry of deep space. They are patterns that remind researchers of either biological processes or deliberate advanced synthesis. And if that weren't enough, density readings point to something that breaks with all models of natural formation. 3I Atlas is not a single, solid block of material. The data suggests it has cavities, empty pockets, and what appears to be a layered build. Think about how planets and asteroids form. Tiny grains of dust stick together, then pebbles, then rocks, all pressed together by gravity over eons. The end result is a compact, solid body, dense from surface to core. Large, stable hollows simply don't survive this random, brutal assembly process. Yet, 3I Atlas seems to ring with emptiness, as if its framework was purposely designed that way, like a geodesic dome rather than a solid boulder. But here is where we enter territory that genuinely challenges everything. All of those anomalies could, perhaps with enough imagination and a rewriting of astrophysics textbooks, be explained away as a once-in-a-universe natural freak. This next fact, however, cannot. 3I Atlas is changing its trajectory, not through violent maneuvers or obvious rocket burns, but through subtle, precise adjustments. We have measured tiny accelerations, microscopic course corrections that gently alter its path in ways that natural forces cannot explain. When Oumuamua showed similar non-gravitational acceleration, the most popular hypothesis was outgassing jets of vapor from sublimating ice acting like tiny rocket thrusters. But as we've seen, 3I Atlas has no visible plume, no detectable vapor trail, no coma formation. Yet, the trajectory changes persist. Our instruments confirm it is happening, but we cannot identify the mechanism. It is as if the object is using some form of propulsion that leaves no visible signature, no exhaust, no evidence of expelled material. And these bursts of movement seem to align closely with the times our most sensitive instruments are able to track them, making it seem less like a coincidence and more like a deliberate design. This is where the story shifts from a scientific mystery to something that feels coordinated. For countless generations, humanity's sky was silent of interstellar visitors. Then suddenly, within a span of less than a decade, we are visited 3 times. In 2017, Oumuamua, the Scout, tests our very ability to detect and question motion that breaks expectations. 2 years later, Borisov arrives, a slightly more conventional but still anomalous object, hinting at foreign chemistry. And now, in 2025, 3I Atlas arrives, combining the most puzzling qualities of both earlier visitors and adding entirely new mysteries: the smooth surface, the stabilized spin, the impossible chemistry, the internal voids, the silent propulsion, and that single, deliberate radio signal. The odds against this happening by random chance are overwhelming. It begs an unsettling question. What if this isn't a coincidence at all? Normally, a finding of this scale would ignite a firestorm of open, global scientific collaboration. Yet this time, the reaction was the polar opposite: an information blackout. NASA's Jet Propulsion Laboratory, known for its public engagement, suddenly restricted all data. Observation schedules for the Webb and other major telescopes vanished from public channels. The European Space Agency quickly followed suit. Formal requests for information under the Freedom of Information Act, a law designed to ensure government transparency, were met with pages so heavily censored they were almost entirely black, marked only with the chillingly vague justification of national security concerns. Think about that. National security in reference to a comet passing through space. It suggests one of 2 possibilities. Either the authorities have uncovered something so world-changing they believe society cannot handle it, or they are facing data they cannot understand and are utterly frozen by fear. So let's change our angle. Picture yourself as a member of a mature civilization, watching humanity slowly wake up. For millennia, we were blind to the wider universe. Then, in a remarkable flourishing in our 21st century, our tools finally grow precise enough to catch these faint points of light moving between the stars. It would be the perfect moment to begin an assessment, a gentle test. You send objects to disturb curiosity. Oumuamua comes first, forcing us to wrestle with motion that breaks our rules. Borisov comes next, bringing material that hints at foreign chemistry. Then 3i Atlas arrives, showing geometric features, internal hollowness, and maybe even making direct, if brief, contact. The pattern is clear. Each visitor raises the stakes, pressing against the limits of what we can grasp. Not enough to cause panic, but strong enough to ready us for something larger. This is the idea quietly shared among some investigators. These are not stray fragments. They are probes, scouting missions, a gentle trial that poses basic questions. Have you learned to notice? Can you drop your assumptions? Are you ready to challenge your sense of reality? This is the moment we stand at a crossroads between two sharply different futures. In one path, 3i Atlas proves to be the most remarkably unusual natural comet ever recorded. That result, by itself, would mark a profound turning point in planetary science and reshape many long-held models. But there is a second path, one that could change everything we think we know about our place in the cosmos. If even a small fraction of these oddities survives scrutiny, if those course changes are truly guided, if a hollow interior is verified, if that radio message is shown to be intentional, then we may be seeing the first confirmed contact with intelligence that did not begin on Earth. For all of human history, we have lived under the assumption that we are a lone consciousness in a vast, uncaring universe. But what if we are not alone? What if we are not the ones doing the watching? What if, from the very start, we have been the ones under observation? As I'm recording this, 3i Atlas continues its silent journey. Every day it travels millions of miles further along its trajectory. At some point in the coming months, it will reach the outer boundaries of our solar system and return to the interstellar void from which it came, taking its secrets with it. Our window of opportunity to study this object is finite, and it is closing. But whether 3i Atlas is ultimately natural or artificial, whether it's a cosmic coincidence or a deliberate message, it has already accomplished something profound. It has forced us to expand our thinking. It has challenged our assumptions. It has reminded us that the universe is far stranger, far more complex, and far more mysterious than our current models can fully capture. So remember this moment. Remember the designation 3i Atlas. Remember that in 2025, something entered our solar system that didn't play by the rules. Remember that it sent a signal, that it adjusted its trajectory, that it challenged everything we thought we knew. Because whether it's ultimately explained or remains forever a mystery, it represents a turning point, a moment when we collectively looked up at the stars and had to seriously consider the possibility that the universe might be looking back.